Sample problem S09-06. Two identical carts traveling in opposite directions are shown just before they collide. The carts carry different loads and are initially traveling at different speeds. The carts stick together after the collision. Three physics students discussing this situation make the following contentions. And then we want to say which, if any of these statements, do we agree, and explain our reasoning. So we'll go through them one by one. Alex says, these carts will both be at rest after the collision since the initial momentum of the system is 0 and the final momentum therefore has to be 0 also. So is that really true? Well, first of all, let's see if her momenta are correct. So P, let's call this guy 1 and 2. P1 is mv1, m1v1, which is 8 kilograms times 20 centimeters per second, is 160 in whatever these units are. And then P2 is going to be m2v2, and that's going to be 4 kilograms, but in a minus 40 centimeters per second because of the direction, and so therefore this is minus 160. And so we can see that when we add them, we in fact get 0 beforehand. All forces of collision, so there's 0 afterwards. So Alex is doing pretty well. We like her answer pretty well. All right, and then Belinda says, if that were true, it would mean that they would have 0 kinetic energy after the collision, and that would violate conservation of energy. Since the right-hand cart has more kinetic energy, the combined carts will be moving slowly to the left after the collision. So let's evaluate Belinda's statements, and what we have here is it true that it would mean they'd have 0 kinetic energy after the collision? Well, that's certainly true. And if that's true, then that would violate conservation of energy, and that's also true, but Alex's response might be, so what? We don't have any reason to think that energy is conserved. They stick together, so in fact we're fairly sure that energy will be lost. It'll be lost to whatever deformation goes on that allows them to stick together, the two hooks locking together, or Velcro sticking them, or whatever it is that makes them, or maybe the cart's just crumpling up. But whatever it is that allows them to stick together means that their shape has to change in some way, so their internal potential energies change, and that energy's got to come out of the kinetic energy. So Belinda's if-then is true, but not relevant. And then the second part says that it's not true that the object with more energy necessarily wins in a collision. The object with more momentum is, the objects that can exert forces on each other will, but not necessarily anything about energy. So for Belinda, we have to say not true. And then finally for Chano says, I think that after the collision, the pair of carts will be traveling left at 20 centimeters per second. That way, conservation of momentum and conservation of energy are both satisfied. But we have already showed that conservation of momentum is not satisfied because, in this case, conservation of momentum requires there to be 0 total momentum, and so they cannot be moving since they stuck together. I'm not exactly sure where the 20 centimeters per second comes. It looks to me like what he ends up doing here is simply subtracting the 20 here from the 40 there, but there's no physical basis for that. So the only person who works out is Alex. Her statements are correct.